So, does your build keeps getting longer? Right? So you extract code into packages. But then the package you extracted exploded the dev time in app. And also, on top of that, it's hard to keep up with the newest version of the tooling and such. Yet, Hasura, it was the same. The build time was like 50 minutes for a single front end. The dev roll-off time was like 5 minutes. So like you type something, you wait 5 minutes to have the feedback. And we didn't have proper tooling everywhere. So we had to make a change. And this is the story of this change. So first, who am I? I'm Nicolas. I'm a staff front engineer at Devfest. I'm also an NX champion. And this is a story from where I used to work at Hasura. Side note, we are hiring. If you're looking for a job, fully remote, and quite a good team, so feel free. Anyway, going back to Hasura. So what was the setup, right? Hasura had two parts, the OSS Codebase, that we then bundle into a library, thanks to extra layers of Webpack, that we then imported into the OSS Codebase. On top of that, the tooling wasn't the same everywhere. So in the open source Codebase, we had TypeScript, ESLint, Jest, Storybook, even Chromatic to do screenshot testing, and end-to-end test. So pretty solid stack. On the Pro Codebase, and as a reminder, we sell the Pro Codebase. This is like the product. We had JavaScript, we have ESLint, and Jest. And that's it. But that's not it. On top of that, we had 1,000 lines of custom Webpack. We had log file management issues, where if you update a package in one but not the others, the application will crash in production. Remember, no end-to-end test on the Pro code. And the CI was very slow, so we wanted a monorepo tool. We wanted something to manage how we build and package our software. And we made a shopping list. So first of all, we wanted to have task orchestration, right? Like build this before that because I depend on this. We wanted to have this dependency graph visualization. I wanted to see from a visual standpoint what import what. We wanted to have consistent tooling, so the same version of Jest everywhere, the same version of Vite everywhere, the same configuration in every single places. We wanted to have project constraints, so we couldn't import the Pro Codebase in the OSS Codebase, because that could leak things that we sell into the OSS Codebase. And we also wanted distributed task execution to be able to speed up the CI by just throwing more runners and having things dynamically scale on the CI. And we wanted to have code generation to be able to say, create me a new library. I don't care how, just do it. And so from this shopping list, we looked at the ecosystem and what existed. First, a bit of a disclaimer. This was done in 2022. So there is new tool that came out since then. One of them is moonrepo, that isn't in this exploratory step, but I will highly suggest you look into it. I'm also an NX champion, but I will also use other tools if it makes better sense. And I also want to shout out every single one that works on those tools. They're usually very friendly and very welcome. So if you have an issue, if you want to erase something, they usually have like Discord, or like just open up an issue if you're blocked. They are just amazing folks. All right, so the first one we looked into is Bazel. Bazel by Google, which is an old one, but very complex. It can take a while to set up properly. But it works very well. We looked into Gradle, because you can do other things than just Java with Gradle. You can do Go, you can do JavaScript, you can do whatever you want. At the core of it, Gradle is just a build system. We looked at Lerna, which was the historical JavaScript monorepo tool management that is now maintained by Narwhal, the company behind NX. We looked at NX, because I've used it in the past when I was working in Angular a couple of years back. We look at Pants, and yes, this is a real monorepo tool that is made mostly for Python, I believe, but works pretty well on front end. And of course, like hype-driven development, we had to look at Turborepo, like Versal, Triangle Company, and such. So we still looked into it, and yeah. So let's see from our shopping list. We wanted task orchestration, and they all can do it. No surprise, right? It's the baseline of a monorepo tool. We wanted to have dependency graph visualization and Pens and Gradle doesn't support that natively. Every single one of them, you could put it on top of the tool yourself, but we didn't want it to have everything on top of it to be manually managed. We wanted to have everything in one box and don't have to deal with it. We wanted to have consistent tooling. Turbo and Learner doesn't support it. You can just run whatever you want. You cannot have constraints and such. We wanted to have project constraints that Bazel and NX supports. We wanted to have distributed task execution that Bazel and NX supports. And code generation, this is where Bazel fell off. I just want to say, like, NX was the one that matches our needs, but it may not match your needs. So keep that in mind. If you want to learn more, there is a website called monorepo.tools that you have a lot of contributors that makes monorepo tools that contribute to a list of features that are not on such tooling. Going back to NX, right? NX have two flavors of NX, package-based and integrated. So what the hell do they mean? The first one is package-based, which behave like a pnpm/cleon/npm workspace. Right? You just have like packages that are isolated. It doesn't have consistent tooling. You can do whatever you want. The migration is like way easier. You just add an NX.json and you're done, basically. But there is still a step between all the libraries, which is the thing we wanted to avoid. Because remember, 5 minutes reload time, this was because of that. So we looked into the other way, which is integrated. Integrated means that every tool is integrated into the whole workspace. It means that every tool is consistent, but the migration is more thoughtful, right? You either have to be forced into the way of NX, or you bend it a little bit. But there is optional step between libraries. And there is plugins. Woo! What does a plugin do? Plugin generates code, right? You have the storybook plugin, add a new storybook, done. Add a new story, done. You have a Vite plugin, create a new lib with Vite, done. You don't have to know all of the tools. That's the beauty of plugins, just wrap things. There is executor. You don't have to know how to run Vite or storybook and such. It's done for you. And there is automatic migrations. A new Jest version came out. OK, NX update, and it will migrate your own code to use the new Jest config and the way of building. And there is a new thing called NX Crystal, which makes this whole migration 1,000 times easier, and I wish it existed before. I don't have time to go into in many depth about what is NX Crystal, but if you want to migrate, look into this. It will help you tremendously. All right, now, everything is good, right? Like, everything is fancy, everything is nice, but we're all engineers, right? There must be some trade-off somewhere. And there are two big ones. The first one is the single version policy, which says that there must be only one version of a dependency and package. That means that in the same monorepo, you have the same version of React or Redux or whatever in the same monorepo. You cannot have two of them. While it's a pain, we can also see it as a build versus loan with interest kind of like system. Let's say you want to update your front end, you only update React once in the whole code base. Sure, it takes a bit of time, but you don't have to do context switching. You don't have to learn everything again. Whereas loan with interest, an update could take months. And every time you have to spin up the context, like, all right, how do I migrate legacy context again? And in the end, it's recommended in monorepos, even without NX. It's like one of the things that is recommended. It's just that in NX integrated, it's forced for you. The second big part is the buying of tools, which used to be very true in the past, that you have to wait for NX to update the tool. But in the end, we're an enterprise customer, right? We don't need to like have the latest version of Cypress. We can wait a week or two, right? Now they work hand in hand with the tool developers. So everything is updated way faster. And there is plenty of escape hatches, right? You could do something yourself to just say, like, you know what, NX, I'm just going to use my own Cypress. I know how to configure it, so I'm going to do it myself. And with NX Crystal, it changed this whole philosophy, where NX integrates inside of the tool instead of like wrapping it, making you responsible for a lot less of like how things are piped together. Now, how do we proceed, right? We know we wanted NX, we know we wanted integrated. How the hell do we do that? And without stopping production. No one has even given green flag to say, like, guys, we're going to spend 6 months rewriting everything. Trust us. That never works. I mean, rarely. So here's the big requirement we had for this change. We wanted to have no code freeze. We wanted to have as little regression as possible, because no one likes bugs. We wanted to adhere to the NX standard to ensure that NX can understand and update the workspace for us. A nice to have is to keep the 7 years of Git history, because when you touch some legacy part, the only thing that saves you is this Git history. So here is the way we proceed. We had a current code base. We created the fresh NX workspace. We imported this code into the fresh NX workspace. We ran build and dev. Is it working? Well, no, it broke, right? And we notified the cause of the breakage, and we broke the current build, so that we fixed the code itself and the tooling. We start again. We identify some of the small tweaks we need to make to NX, and at what point it worked. And thanks to this, in case we didn't have time to finish the migration, at least we improved the current code base, because the current code base always was improving, even though it wasn't still using NX. And so what are the tweaks we needed to make to NX? The first one was TS path aliases, because we relied heavily on them, and migrating them was a pain, so we did it afterwards. We had to add Node.js fallbacks, because even though no front-end, in theory, you should use crypto or HTTP, everybody does that for some third-party dependencies they don't manage. We had to make a small number of Webpack configs, about 20 lines, which is way less than like nearly 2,000 lines. And we had to disable ESLint rules, because it turns out NX ESLint was way stricter than ours, for good reason. What about our code? Well, first, we had to use proper CSS modules. We're using CSS modules without the extension, so we had to rename a bunch of files. That wasn't too hard. The second part is to use relative path instead of absolute in CSS and TypeScript. The same, it wasn't that complex. We had to fix path import that relied on a Webpack config. We had to update Jest and TypeScript, because we were in a very old version. We had to update the entry points, so that they can export components instead of just mounting them. But the worst part is we had to fix secure dependencies issue, like a lot of them. You don't even see them on the screen. There are so many of them. And Webpack 5 couldn't handle it, and it wasn't able to start the application. It was like, I don't know from where can I start. It's just going to like hang. So through a lot of work, we managed to get it down to 95 loops, which is still way too much. But given like 1 million line code base, it's pretty OK. And Webpack was able to understand it. And so that's how it looked in the end. We had one Pro application that imported the library from the Pro. We had the OSS library that also imported into the OSS application with the end-to-end test on top of it. And now it was time for the big switch. The big switch was 4 commits. The first one to clean the imported workspace. Second one was to migrate the old workspace into the new one. Third one was to add an archive for OSS transition, because we had pull requests from third parties. And the fourth one was to apply the node tweaks, and then it's done. Total freeze time was 3 hours for the whole migration, and this was due to CI just being slow and flaggy that day, because Bullkite had an incident. So in the end, pretty impressive. So what about the result, right? What about the result for the engineers, but also for the users? 0 bug in production. Because we had this incremental approach, we managed to have the thing worked out in the way that we were coding bugs before, because we were modifying the current code base, and nothing was bugged in production. But this was surprising. We managed to get 70% of the bundle out. We went from like 43 megs to 30 megs, because then we had updated Webpack config. We had a single context for Webpack, so Webpack could tree shake more aggressively. And thanks to this, we had like sales engineers calling us like, wow, what did you do? The app was like way faster now. I can finally use it. Yeah, that was this bad. And the local dev is 30x time faster. So from like 5 minutes to like 10 seconds, it changed the engineer's life. And the CI, 16% faster because of caching, and that's helped a lot. So that is good and all, but like, is that the end? Could be. You could be good like that. You don't need more. But you could do more. You could do architectural decoupling and like split libraries into smaller packages. You can do that with lint rules with NX. It looks like this. It's not the best way of writing them, but you basically say you have three scopes here, and those scopes can import those scopes. Visually, it looks like this. You have like 3 boxes within your monorepo, and you can say this one can be imported by this one, but not by this one. The second thing we did was to uniformity of our tooling. And this we did through a custom web plugin, which isn't too complex, thanks to an NX generator to create plugins. Meta. And one of the features of the plugin that we made was to create a library with the modification we needed to make, the test setup, and such. Because in the end, thanks to the plugin, you get all of the specificity of your tooling, how to like build, how to like run, all of the engineering minds and into automations. Because in the end, coding on a code base shouldn't feel like this, where you're afraid of touching everything, and you don't know like who is impacted by this change, like what this is going to break. But more like this, a happy dance, like just like pick, I'm going to fix this and this and this, and you're done. Thank you.